Hello everyone. Welcome to our panel on security in digital asset custody. First of all, I am Ahmet. I'm working at Paribus Custody as an engineering manager. Today we have 3 speakers, including myself. I am very honored to introduce our speakers. From TÜBİTAK, we have Fatih Birinci, lab manager, and bringing valuable insights from perspective of regulation and applied cryptography side. And from UK, joining us from De Montfort University, Dr. Muhammed Bingöl, bringing us, program leader for computer networks and security, who will share technical perspective on secure infrastructures. Today we will cover both security and regulation perspective of the custody solutions. So let's begin. When we talk about cybersecurity today, we usually start with software security, how we design application, encrypt data, and patch vulnerabilities. But the reality is, software security alone is never enough. So all software ultimately depends on the hardware, whether it's in the cloud or any physical device. If someone gains to access that underlying machine, they can interfere with or observe the system, no matter how well the software is designed. To dive deeper into this, I would like to turn to Fatih Hocam. Why does hardware remain so critical as a root of trust?
Thank you for, first of all, inviting me to this wonderful event. I hope you will enjoy too. Software security advanced a lot, but actually it is the underlying hardware that supports security. I can give examples that software security cannot achieve. For example, true random number generator, tamper resistance, and as well as side channel analysis. Why we need hardware? Because the private keys in the crypto asset world is very important. Maybe the utmost important thing, and we should protect them. Hardware actually provide secure environment for their processing and storage. But actually, hardware are not just hardwares. Hardwares composed of softwares, firmwares, and actual hardwares, which we sometimes call silicon of trust. If these components are securely designed and tested according to some standards, that gives regulators and institutions the confidence and assurance that indeed the operations performed on these devices are trusted and valid. That's why I think the hardware will remain relevant. Okay. Thank you.
Thank you, Hocam. I would like to hear from Muhammed Hocam. Building on that, what breaks first when we rely on single private key, and what we have learned in last couple of years?
Okay, yeah, thank you very much, and thanks again for the organizers for inviting me and Paribus also hosting this panel. And so, yeah, the private key, as you mentioned, Ahmet. So if there is a lesson we should keep in mind and we should keep learning, it's that the single private key is the single point of failure. But unfortunately, still we have such incidents, and it is still going on, in the real world. So, for example, if you want to, remember similar examples like So the CoinEx, recently they announced that the $70 million, just evaporated, shortly because of their hot wallets, And also, if we just zoom up, so last year, 2024, 2.2 billion cryptocurrencies are, just hacked. And also, currently now we are in 2025. So recently, it is like, we almost reached 2 billion, lost. So this number will, it's increasing. So what we are learning here, actually, so we are keeping the money in wallet. Actually, what do we mean by keeping the money? Actually, we are not keeping the money, but there are two things that the wallets are, the two functionalities, I would say. One of them is keeping the private key as a secure storage, and also generating the signatures, right, for the transactions. But the thing is, if we only rely on a software-based system, as Fatih Hocam said, so we are, having this type of problems, and we should kind of, anchor the hardware components, into the system, and we should also solve this problem in the protocol, levels as well, in the cryptographic protocol levels as well. So we shouldn't rely on only software-based systems, and we should also, have solutions that also involve cryptographic level, security.
Yes. Yeah, exactly. What we are all mentioning is that nothing is absolutely unbreakable. But when you add hardware protection and attestation with cryptography, that distributed trust, the whole security model becomes much stronger. And the key point is I think software gives us flexibility, and hardware anchors assurance, and the missing piece is removing single point of failures. As you mentioned, private key is central to digital asset protection. What are the key concerns around the private key security from perspective of regulators, end users, and cryptographers?
Yeah, thank you. Actually, I can answer these questions in cryptographers' point of view, and maybe Fatih Hocam can, answer this, in the regulatory, point of view. So first of all, as we mentioned, so the digital assets are kept, in wallet, and also these are, very valuable. So and we said that we shouldn't rely on single private keys. So what we should do? Actually, we should not keep single private key, but we can split this. So when you split, you can use multi-party computations, kind of, if you go a little bit, technical, kind of threshold signatures. So why we say threshold signatures? Because, sometimes we may need availability. So when we teach cybersecurity, we have CIA threat. So it is confidentiality, integrity, and availability. It's not the CIA of USA, but it is the the pillar of the cybersecurity. So we say sometimes some signers may not be available, so we use threshold cryptography. So what do we mean by threshold? For example, you distribute the key, you split the key into 10 pieces, or let's say n pieces, and then you, if 3 of them, 4 of them, or 2 of them comes together, they can form a signature. And so that with this signature, you can authorize the transaction. So this is how, just theoretically, how the threshold schemes works, to just avoid single point of failure. Actually, this is so. When we split the things, we need to also, think about other aspects. So we talk about the hardware. Maybe we want to keep some of the parts in the hardware components, so that we also use this signature part, and this is coming from the hardware. And yeah, maybe Fatih would like to add
from
extra
government
things for
and
the-
regulatory side, yeah.
Actually, from the regulatory point of view, in Turkey, government's priority is to protect citizens' assets in the exchanges. Tokenization and real-world assets may come later, but all of them rely on secure custody. So how we achieve this? We should understand the landscape first, attack landscape actually, because it is different than what we accustomed like in the traditional finance. Because billions can be moved instantly in crypto world with very low fees actually. And attackers, if they hack or get some money, transfer it many times, and they use anonymizers and mixers. So tracing and sizing or getting these money back is incredibly difficult, maybe impossible.
Maybe impossible.
So, and if you look to the attackers, their sophistication is also very high. We see government level or government-baked attackers. We saw it in Bybit hack. It was a Lazarus group from North Korean. We saw it on Iranian and Israeli war. There was also state-baked hacks. So the sophistication of the attackers also very high, and their determination is also very high, because they think they cannot be catched, or their money cannot be seized. So this is the case, and we should secure the assets accordingly. In Turkey, self-custody still be possible. Citizens or end user who wish to control their assets on their own can use MPC wallets or other tools. There are many tools now. Even in ledger level, there are access control mechanisms on smart contracts called account abstraction. They can also use these types of tools.
Thank you, Hocam. I want to move to talk how secure hardware like HSM are used in custody systems. We have hands-on experience a bit about this field, and let me share a bit about that first. In our operation, HSM is holding cryptographic secrets which manage wallets, authorize and sign transaction. And importantly, this module can also operate in offline scenarios, and these offline scenarios give an institution an additional layer of confidence. It means their most critical assets stay disconnected from the internet. And this ability is especially valuable because it's their most critical, most sensitive operations completely disconnected from all kinds of risks of the internet. That's how we approach. I'd like to, from both of you, Fatih Hocam, maybe you can share the regulatory and government sides of how HSM should be positioned in custody system, and maybe Muhammed Hocam, you can expand in technical side.
Actually, as we talked before, hardware modules provide secure environments that regulators and institutions trust that their operations are actually performed securely. But actually, hardwares are dumb devices. The smartness is where the servers who manage these HSMs devices. So the HSMs are not enough alone. The surrounding system, as you mentioned, should be secured. So there should be a holistic approach, maybe Muhammed said, not just technical controls like HSM, but also physical controls, because without physical security, there is no security at all. And there should be administrative controls too, because how many personnel should use them, how they use them, for example, segregation of duties, etc., should be put in place.
Hocam.
Yeah, as mentioned, we shouldn't only rely on the software thing. So we want to involve hardware components as per the regulatory, perspective. And also, if I talk about the cryptographic perspective, we always, involve the cryptographic also solutions into the system, and this should be also, this is also required. Because even if we put a secure hardware system, it might be bypassed. So the cryptographic also protocol should also support this idea. So if we consider the conventional threshold schemes, what we have, actually, the system is working in a flat way. So what do we mean by flat? Every participant, they have the same power, and let's say if you build a kind of T out of N threshold system, so any T comes together, they can operate as signed. But if you want HSM or any hardware secure module to be involved into this system, we need to also, involve it in the cryptographic way, so the conventional threshold systems may not serve in this way. So we need a kind of, hierarchy, as we discussed in the earlier session. So you can put the HSM into the hierarchy so that it should go through the HSM or secure hardware. So that at least one hardware module also participated in the signature, and it is kept in the loop. As I said, just to sum up this idea, so we require the hardware components, but we also support these components with the cryptographic, solutions.
Yeah, thank you, Hocam. I am getting there. We have covered the secure hardware component, but the next piece of the puzzle is secure enclaves like Intel SGX. How do you see their role alongside HSM or this kind of hardware secure hardware model?
Okay, secure enclaves, trust execution environments are originally developed for the needs of cloud security, actually, where multi-tenant devices sharing shared memory, and there was another threat landscape there, but they are useful for, as I mentioned, that they are usable for controlling HSMs or policy enforcement or similar things. Because secure enclaves actually provide secure attestation, as you mentioned, that these host devices are actually boot securely and they are in the correct versions, and your application actually doesn't change. And there is a secure binding mechanisms which provide if the secure enclave is actually boot securely and in the correct state, then the data can be decrypted. Otherwise, cannot be decrypted. So together, secure enclaves and HSMs, they provide holistic and better security. I think.
Hocam, do you want to add something?
Yeah, so we discussed about SGX and HSMs. So in simple words, actually we can see the HSMs like a secure vault. It's like a storage, and the SGX are clean rooms, you know, that supports the HSMs. We are not keeping the private keys, you know, in the HSMs. Sorry, in the SGX. So what is the functionality of SGX? It could be, if I give a kind of example scenario. So we want, for example, include the HSM in the loop, in the signature loop. So we keep one partial key in the HSM, okay? And then, but in many protocols, we need signature aggregators, okay? And this, you know, part would be good if it is, you know, run in that clean room, okay? So it is aggregated, and the piece of part of the signature taken from the HSM, ideally from a kind of hierarchical way, so that it is always in the loop, it is always participating, so that the signature is, you know, aggregated within the SGX. I think this is, you know, a kind of example architecture that, you know, help us to understand these components. Actually, so SGX are also, you know, they are important. They are also used in different devices. So we know the smartphone manufacturers like Apple, they also have the secure element. So why they are separating this, you know, part? Because they want to do, you know, some critical operations in that secure part, what they called the secure element. So it is like, you know, they are separating some part of the things. You don't do, you know, you don't force everything to do in the HSM because it might be slow, but you can facilitate and you can, you know, speed up the process using, you know, some auxiliary secure part with those components.
Thank you for those insights. Let me also bring in our perspective. In custody setup, we use HSM and SGX with MPC. The HSM protects blockchain private keys and approval public keys, store approval public keys, while SGX runs approval ceremonies and create those signatures. SGX send those signatures to HSM, and so those signatures and transaction data to HSM. Once HSM verified, it signs transaction that related blockchain private key and send to the network. And this with this way, approval stay in SGX and enforcement in HSM, and key never leaves the secure boundaries.
Yeah, which is very good. So this is what also very parallel what I just explained. So yeah, I know Parvi is also doing a really good job in this area. So you are doing, you know, initiative works. So you have Parvi custodian, custody, which is, I think, a separate group. So I think, yeah, working in those topics and trying to promote this type of technologies is really good.
Thank you. It's very honored to hear something from you. Thank you for sharing for perspective of SGSM and SGX. To wrap up, let's talk about the future. What lies ahead custody systems, and what excites you more about this field? Hard question.
Okay. As we talked before, the threat landscape is very different in this sector. The threats or attackers' ability and determination is high. So I imagine cooperation between custody and institution. Actually, they are competitors, but if they can manage to cooperate in technical areas, it can enhance their infrastructure and security, I think.
Hocam?
Yeah, I think to wrap up, actually, we have lessons learned. Actually, unfortunately, still the problems are coming from the old-fashioned systems that keep the single private key into the into their wallet. So we need to kind of level up this with the custodian systems by splitting the keys. But the thing is, the literature is always also it's like a horse race. So it's not standing as it is. So the things that we talk about in last year, it's not valid today. So it's evolving really fast in this area in terms of the theory and also the practice. So we should also keep updating us, and also we need to, as Turkish citizens, we need to also improve ourselves, and we need to be in the state of the art. So we are doing some good works with TÜBİTAK Bilgem as well. So I'm in Demonstrator University, but I'm also doing works with TÜBİTAK Bilgem as consultancy. So we are working on also improving the secure wallet system in terms of theory and also practice, because we have really good power. So we can do, and we can, because this sort of things requires different types of disciplines. Like you need to know the cryptography, you need to know good mathematicians, you need to have good developers, you need to have also hardware, embedded system designers and also programmers. So these are not easy, especially the wallet systems are the weakest part of the blockchain systems, and also the most important part, because you can just doing by few things, you can just evaporate the assets in a short amount of time. So we need to put efforts in this area, and this is quite important. And we are trying to keep the state of the art in this area. And I also appreciate our young researchers to also get into into these systems as well. Yeah, thank you.
Thank you. Thank you for those insights. From my perspective, the next step are orchestration and adaptability. When I think the future, the custody and its security mechanism becoming invisible, but not invisible in the sense of being unimportant. Invisible like infrastructure, you don't notice it. It just works, and it just works at any scale. We are we are almost at the end of our session. Thank you. I would like to thank to all our speakers for giving valuable insight, and thank you all to joining us today. The takeaway is this: custody systems is not just protecting keys. It's about building trust, resiliency, and system that can be adapt regulatory and technology. With that, I think with that we can wrap up.
Yeah.
Thank you.
Thank you.
Thank you.